Our aim is to use inverse operations to solve multi-step equations. So we're going to have some extra steps in here. It's not just going to be 2 steps, but it's going to be no big deal. First problem that I want you to do today, that we are going to do together, is this problem. That's the perfect response. Ricardo says, dang, that looks really complicated. Now, I'm looking for a word that is the opposite or an antonym for the word complicated or complex. Easy is one. Somebody give me with a raised hand another. Something that is a synonym for easy. Sadie. Simple. So this looks very complex. I would much rather it be simple. So mathematically, we should probably do what? Simplify it. So what I can do here is, you see that I've moved over on the board over here, and I've completely started to ignore the right-hand side of the equation. I'm completely ignoring it. The reason why I'm completely ignoring it is because I'm thinking to myself, hey, all right, this is just an expression. We did this before. I can simplify this expression and make it a lot easier. All right? So what things can I do with this expression to help simplify it? Mr. Posey. Start with the leave chain switch on this subtraction over here. All right, then what? Jacqueline. Commute my like terms. Then what? Mr. Espinoza. Combine my like terms. Negative 27 plus 40 is 13. Plus negative 5x plus 3x. Opposite sign subtract. Take the sign of the larger number. Negative 2x. Now, this is as simple as this expression gets. Now we can go ahead and bring back the other side of the equation. And now I'm going to ignore everything above. That was unintentional. No big deal. Because I know we had negative 2x plus 13. And I'm going to ignore everything above that, because this is just a simple equation, 2 steps, that we've done many, many times before. So what do I need to do to solve this simple now 2-step equation, Nafisa?
You need to add a negative 13 to the positive 13 and then add a negative 13 to the negative 33.
Awesome. She's telling me to do the additive inverse of adding 13, which is add negative 13. She's also making sure that I do it to both sides. 13 plus negative 13 adds up to 0, leaving me with negative 2x on this side of the equation. On the other side of the equation, I have negative 33 plus negative 13. That gives me, like signs add, take the sign of the larger number, negative 46. Now, it's like I've simplified this even further. Now I've got a simple 1-step equation. Mia, how am I going to solve this?
Divided by negative 2.
Dividing it by negative 2.
On both sides.
On both sides. Thank you for the clarity on that. That gives me x is equal to negative 46 divided by negative 2. 46 divided by 2 is good date or bad date?
Good date.
Good date. So we're going to leave it positive. Boom. X is equal to 23. All right.
Solved it.
Yeah, question. That would suggest to me that you added a positive 13 to both sides. That also suggests to me that you were working ahead of me. All right, next problem. ECs, what's your favorite number between 1 and 25?
7.
Shh. Wrong. The answer was 24. Just kidding. We'll use 9. All right. So, looking at this, again, this looks a little bit more complicated than the problems that we were doing yesterday. Therefore, since it's so complicated, we should probably make it more simple by doing some simplification. So, I'm going to ignore the right-hand side of the equation and look only at the left-hand side of the equation and say to myself, hey, let's simplify this. How can I simplify this? What's the first thing that I need to do? Mr. Matlock.
So we gotta do some grouping symbols.
There are some grouping symbols. But, Andrea, what do you think we should do first? Leave chain switch. Now, Mr. Matlock, chance to redeem yourself. What do we need to do?
Now we gotta do them grouping symbols.
We got to deal with those grouping symbols. Now, how do we deal with those grouping symbols? Because I can't add x plus 3. How do I deal with those grouping symbols, Renee? Yeah, we're going to use the distributive property to distribute in here. All right, so I'm going to get 3x plus negative 2x plus negative 6. Negative 2 times 3 is negative 6 is equal to, well, we're still not simplified yet, so I'm not going to worry about what it's equal to. Now I'm going to go ahead and combine my like terms. 3x plus negative 2x is 1x. Actually, we can just write that as x. So I get x equals 6, or x plus negative 6 is equal to, now I'm going to go figure back out what was over here. Oh yeah, we said it was 9 because that was EC's favorite number between 1 and 25. And we're going to finish solving this now new equation, very simple equation, x plus negative 6, by doing what? Genesis. Additive inverse, so we're going to add positive 6 to both sides. So x is equal to 9 plus 6, which is 15. Any questions about this problem? Awesome. Because I believe in you so much, I am going to only pick one more problem, but it's going to be a tricky one. One half times x minus 2 minus x minus 3 is equal to, Jacqueline? 14. Sorry, anybody who said anything other than 14 was wrong. All right, so again, this looks very complicated, so I need to make it simpler by simplifying. So I'm going to ignore the right-hand side of the equation for now, and I'm going to start trying to simplify this. Mr. Posey, what is the first thing I should do en route to simplifying this? He says I should make the 1/2 a 0.5. I could do that. It wouldn't hurt me, but it also really wouldn't help. It depends on whether you do better with decimals or with fractions. So I'm going to go ahead and leave it as it is for now. So we're going to leave chain switch instead. And that first leaf chain switch is super easy. Nothing going, nothing, no big deal there. But the second leaf chain switch, well, what's going to go on here, right? Negative x, right? Okay. Perfect. Yeah, so this leaf chain switch, as we know, we cannot leaf chain switch through a grouping symbol, so we just put that -1 out there. Because Elmer, what's going to happen with that -1? It's going to be distributed in. Very good. So now I've got two distributions to do here. 1/2 times 1x. 1/2 times 1x is
1/2 x.
1/2 x. 1/2 times -2. All right, I'm going to write that one out to the side. 1/2 times -2. Make it over 1. Cancels out, but it's a bad date, which makes that -1. Second distribution, I have -1 times 1x. -1 times 1x. Joseph, -1 times 1x.
Joseph, he asked you a question.
-1 times 1x.
Oh, I know that.
-1x. -1 times -3. 3. All right. So we're still not simplified here, but this is en route to making it more simple. So the next thing I should do is what? Kevin. Yeah, commute my like terms. So I'm going to end up with 1/2 x plus -1x plus -1 plus 3. Now I need to combine my like terms. This is where things get a little bit tricky here. I have a 1/2 x plus a -1x. All right, so 1/2 plus -1, make it a fraction, -1 over 1, get common denominators times 2 over 2. It's going to make -2 over 2. I have opposite sign subtract. 2 minus 1 is 1/2. Take the sign of the larger number. Was the -2, so -1/2 x. Plus -1 plus 3 is a +2. So we look completely simplified now. So I can bring back the other side of the equation. And now we have a simple two-step equation. Mr. Ross? What were you going to say? I would have been happy if you were going to ask a question about where we got, or if you were going to tell me what the next thing to do was. Either one I would have been fine with. Yep, absolutely. So we're looking over here. We had it to this point where we had commuted our like terms next to each other. So now we just needed to combine like terms. This one over here was the easy one. We had -1 plus 3, which was 2. And over here we had the complicated one where we needed to add 1/2 and -1. So I did that work over here to the side. I turned -1 into a fraction, -1 over 1. And I gave it the same denominator by multiplying by 2 over 2. So I had now 1/2 and -2 over 2, which is opposite sign subtract. So I subtracted 2 minus 1. That's where I got the 1/2 from. I took the sign of the larger number, which was over here. We could see was the -2. So I got -1/2 x. Okay? All right. So now we've got this equation to solve. Andrea? All right, so Andrea thinks that this should be a -3. Anybody who has any information as to whether that may be right or whether that may be wrong? Sadie. You should be listening to Sadie. She's trying to answer your question. Why is anybody talking right now other than Sadie?
We're still recording.
Yeah, I know. It's still recording. And this is going to be really embarrassing when I upload it like this because this is the only class period that I have a video for.
What?
Sadie, answer Andrea's question, please.
It's wrong because if you have the original problem, you can switch. You've got a -1, and then you can switch inside of the minus again, and it's a good thing.
So we have the leave change switch outside and the leave change switch inside. The one on the outside would force us to distribute in that -1 times the -3, which was our good date, our +3. So, coming back over to this problem. What do I need to do to solve this? Isaiah.
What you need to do is put -1/2 x plus 2 plus -2. Well, add the additive thinking.
Additive inverse?
Yeah, and then equal to 14 plus -2, which will give you 12. And you could cross out the 2's. And then you have to do the cancel out with the 14.
So we have the inverse operation here now for the multiplication of -1/2. Mia?
Oh, so you have to flip the second fraction, flip that, and then multiply it to that and
So we are multiplying by the reciprocal. -1 cancels out with -1. 2 cancels out with 2. 1 times 1 times x is x. And -12 times a -2 would be 24. That was the correct answer. Good date or bad date? Good date. Questions? All right, key point or key points. Genesis. Do the steps one at a time. That's always true for showing our work. Not necessarily a key point for today, but also important. Hervey? Simplify both sides of the equation, then solve. So that's really our big key point for today, is knowing that when we have more complex equations, we should simplify them, and then we can solve them using inverse operations. All right?